Hey friends, welcome back. Today we're diving into the fascinating world of the bizarre blood of horseshoe crabs. We'll explore how these ancient creatures survived millions of years, why their blue blood is so vital, and the quiet ways they protect human health. This video is here to help you relax, unwind, and maybe even drift off into a calm, sleepy wonder. But fair warning, you might also end up wide awake with awe at just how extraordinary these crabs really are. Before we sink into the story, if you enjoy this gentle journey, a like or subscribe helps the channel grow, and we'd love to know where you're watching from. Whether it's a cozy bedroom in Seattle, a hammock in Lisbon, or under the bright lights of a late-night diner in Nebraska. Now, take a deep breath, settle in, and let go. Let your mind drift like mist curling over a quiet pond at dawn. So put on your headphones. Close your eyes. It's made for relaxation and learning. Ready? Let's begin. On warm summer nights along the Atlantic coast, something extraordinary happens. The waves roll in, the tide rises, and from beneath the sand, thousands of armored shapes begin to stir. Their shells glisten in the moonlight, their long tails dragging lines across the beach, their strange legs shuffling them forward. They look like something left behind from the dawn of time, misplaced among the gulls and beach-goers. These are horseshoe crabs, creatures so ancient that they have outlived the dinosaurs, the ice ages, and nearly every great extinction event in Earth's history. To watch them climb ashore is to witness a living fossil in motion. The horseshoe crab doesn't really look like a crab at all. Its body is shaped like a hard helmet, smooth on top, with spiky edges that hint at its armor-like toughness. A long, pointed tail called a telson stretches out behind it, looking dangerous but mostly harmless. Beneath the shell are legs tipped, with pincers, gills shaped like folded pages of a book, and tiny mouth parts that chew food right in the center of their body. To many people, this creature looks alien, like it was designed on another planet, but in truth, it belongs deeply to this one, carrying with it a story that stretches back more than 450 million years. That's almost twice as old as the first. Dinosaurs. If you could roll back time, past the rise of humans, past the age of mammoths, past even the giant reptiles of the Mesozoic, you would eventually arrive in an ancient sea where the first horseshoe crabs crawled along the ocean floor. They were already wearing the same strange armor, already using the same tail for steering and righting themselves, already carrying their bodies low to the sand. Across mass extinctions that wiped out 90% of life, across shifting continents and changing climates, the horseshoe crab endured. Paleontologists sometimes call them living fossils, though in truth they've changed in subtle ways, but their overall design has proven so successful that nature simply kept it. The horseshoe crab's survival is impressive on its own, but what makes them truly bizarre is not their shape, not their age, but their blood. Unlike ours, it isn't red. It's a milky metallic blue, the color of copper left out in the rain. When exposed to the air, it glows with an eerie brightness, as though it doesn't quite belong to Earth. This strange blood has a property so unique, so valuable, that humans have come to rely on it in ways that connect the survival of our species with this ancient creature from the sea. To understand why, we first need to look closely at what makes their blood so different. In humans, the iron in our hemoglobin gives blood its bright red color. In horseshoe crabs, that role is played by copper. Instead of hemoglobin, they have a molecule called hemocyanin. This copper-based molecule binds with oxygen and carries it through their bodies, turning the liquid inside their veins a brilliant, almost electric blue. It's a reminder that evolution doesn't always follow the same blueprint. Life can solve the same problem, moving oxygen using different chemistry. But hemocyanin isn't even the strangest part. Hidden in their blue blood are special immune cells called amoebocytes. These cells act like tiny alarms designed to detect bacterial invaders. When they sense certain toxins produced by bacteria, they don't just attack, they clot. Instantly, they create a gel-like barrier around the invading bacteria, sealing it off before the infection can spread. In the open ocean, this helps horseshoe crabs survive in muddy waters filled with microbes. For humans, it would become the foundation of a billion-dollar industry. Every vaccine you've ever taken, every IV drip that's entered a hospital, every pacemaker or artificial hip that's touched a patient's bloodstream, it all depends on the bizarre blood of horseshoe crabs. Scientists discovered that their clotting reaction is the most sensitive natural detector of bacterial contamination ever found. A few drops of horseshoe crab blood can reveal whether a medical tool is safe for use. Without it, modern medicine as we know it would look very different. It is one of the strangest relationships in history. A creature that looks like it belongs. In a prehistoric ocean has become a guardian of human health in sterile labs and hospitals. The fate of patients around the world is tied to the blue blood of an animal that still crawls ashore in the moonlight, doing what it has done for hundreds of millions of years, laying eggs in the sand, ensuring its survival, unaware of the role it plays in ours. Yet the story of the horseshoe crab is not just about its usefulness to humans. It is also about resilience, survival, and mystery. For centuries, coastal communities saw them as little more than pests. Farmers once collected them by the wagon load, grinding them into fertilizer. Fishermen used them as bait. Beachgoers avoided their sharp tails, thinking they could sting. Few realized that these awkward, armored wanderers carried within them one of the most extraordinary substances on Earth. Even now, as science marvels at their blood, the horseshoe crab remains humble and strange. It lives a slow life, spending most of its time buried in sand, feeding on worms and clams. It grows by molting, shedding its old shell, and forming a new one, sometimes more than a dozen times before reaching adulthood. When it finally matures, it begins a ritual that is repeated across the ages, crawling ashore in vast numbers during high tides of spring and summer, the males clinging to the backs of females as they release millions of eggs into the sand. These eggs in turn feed migratory birds like the red knot, king the ancient crab, to creatures that fly thousands of miles across the globe. If the horseshoe crab is a survivor, it is also a keystone, holding together strands of ecosystems and human health alike. But survival is never guaranteed. The more we have discovered about the value of their blood, the more we have taken from them. Each year, hundreds of thousands are captured and bled, their blue liquid harvested for testing. Most are returned to the sea, but many do not survive the process. At the same time, their spawning grounds shrink as coastlines are developed, and their eggs are harvested as bait. The very creature that has endured for hundreds of millions of years now faces challenges created in only the last few centuries. The story of the horseshoe crab is a story of deep time and urgent present. It stretches back to the Cambrian seas, yet it touches the needles and vials of today's hospitals. It is both ancient and immediate. And it begins with a question that sounds almost unbelievable. How did this odd, armored creature become the key to protecting human life? That answer lies in its blood, blue as the twilight sky, strange as the creature itself, and more important to us than most people realize. To truly appreciate it, we must step into the world of the horseshoe crab, its ancient history, its biology, its role in human medicine, and the complicated future that now lies ahead. If you were to stumble across a horseshoe crab for the first time, maybe washed up on a beach after a storm, you'd probably pause, tilt your head, and wonder what on earth you were looking at. At first glance, it doesn't fit into any familiar category. It's not shaped like a crab, despite its name. It doesn't crawl like a turtle, though its shell suggests one. And its tail, long and dagger-like, looks as if it belongs to a scorpion. For centuries, people thought of them as bizarre misfits of the shoreline, armored mysteries left behind by the tides. But their anatomy, once you begin to explore it, tells a remarkable story of survival. The first thing you notice is the carapace, the hard, domed shell that covers most of the body. Smooth, horseshoe-shaped, and often tinged brown or green, it looks simple on top. But turn the creature over, and an entire alien world is revealed. Beneath that armor are legs arranged around a central mouth, gills folded like books, and sensory organs that can pick up vibrations in the sand. Every feature seems strange, but each has been fine-tuned by millions of years of trial and error. Start with the legs. The horseshoe crab has 10 of them, each tipped with small pincers. Unlike a spider or insect, it doesn't have jaws. Instead, its legs serve double duty. They grasp food, worms, mollusks, bits of algae, and then pass it along to the center of the body. At the very core sits the mouth, round and toothless, waiting to receive the meal. As the legs move, they actually grind the food, breaking it down before it even reaches the mouth. Imagine trying to eat a sandwich by rubbing it with your hands until it became soft enough to swallow. That's essentially what the horseshoe crab does. Just behind the legs are the gills. They are called book gills because of their layered, page-like appearance. With every ripple of water, these delicate structures fan open and shut, exchanging oxygen for carbon dioxide. They work so efficiently that for short periods, horseshoe crabs can survive out of water. When stranded on a beach at low tide, they simply keep their gills moist by using movements of their limbs. It's a skill that allows them to bridge two worlds, sea and shore, during their spawning runs. And then, of course, there is the tail, the telson. Long, rigid, and pointed like a spear. It looks dangerous, but it isn't a weapon. Instead, it functions as a lever. If a wave knocks the crab onto its back, the telson digs into the sand, helping it flip itself upright. Without it, many would die stranded. Yet its intimidating look has led countless beachgoers to believe the crab can sting, a myth that persists even today. Perhaps the strangest part of their body, though, is their vision. Horseshoe crabs carry not one, not two, but up to 10 eyes, scattered across their body. 2 large compound eyes sit on top of the shell, each containing thousands of individual receptors, giving them a wide, panoramic view of their surroundings. These eyes are surprisingly sensitive, especially in low light, helping them navigate during nighttime spawning, but they also have smaller eyes along the shell, near the tail, and even near the mouth, detecting changes in light and movement. To us, their world would look dim and blurry, but highly responsive to motion, a system more about survival than detail. What's fascinating is that horseshoe crab eyes have played a key role in science far beyond the beach. Researchers have studied them for decades, uncovering details about how vision works in other animals, even humans. The electrical signals in their optic nerves helped scientists learn how eyes process light into images. So in a sense, these creatures not only guard our health with their blood, but also helped us understand the very act of seeing. Their nervous system, though primitive, is efficient. It doesn't have a brain in the way we imagine one, but rather a series of nerve clusters that process information. This decentralized system is part of why they've been so adaptable for hundreds of millions of years. There isn't one single weak point. Instead, the body is controlled in sections, a method that has proven resilient across geological ages. When you take in all of this, the armor, the legs, the book gills, the tail, the scattered eyes, it becomes clear that the horseshoe crab is built not for elegance, but for endurance. Every part of its body is designed with one purpose: survival. That design is what has carried them through asteroid strikes, mass extinctions, and climate upheavals. What seems alien to us is, in reality, a masterclass in evolutionary engineering. And, yet, their appearance has shaped how humans have treated them. For much of history, people didn't see a survivor, they saw a nuisance. The hard shell dulled fishermen's nets, the sharp tail was feared, their numbers seemed endless, crawling ashore in such swarms that beaches could be carpeted with their shells. Farmers in the 19th and 20th centuries collected them by the millions, hauling them off to be ground into fertilizer or chopped into bait. Few bothered to ask what role such a strange creature played in the larger ecosystem. Few thought to study the details of their blood or their eyes. It was as if their alien form blinded us to their deeper value. Only in the last century did science begin to peel back the layers of their anatomy and recognize its wonders. The book gills inspired studies of respiratory systems. The optic nerves taught us about vision. The copper-based blood, with its clotting amebocytes, became the foundation of biomedical safety testing. Piece by piece, what once looked like a prehistoric oddity revealed itself as a blueprint for resilience and discovery. And here lies one of the great ironies of the horseshoe crab. Its alien body, so often misunderstood or dismissed, has turned out to be one of the most useful designs for human knowledge. What was once fertilizer and bait became a cornerstone of modern medicine. What was once a nuisance on the beach became a model organism in laboratories. What was once feared for its tail or ignored for its strangeness became recognized as one of the most extraordinary creatures to still walk or crawl among us. The anatomy of the horseshoe crab is not just a curiosity. It is a lesson. It shows us that survival does not always require beauty, speed, or intelligence in the way we define it. Sometimes it requires armor, patience, and a chemistry so bizarre it seems almost magical. The horseshoe crab is not elegant, but it endures. It is not graceful, but it thrives, and in that endurance lies its true brilliance. On a laboratory bench under bright, sterile lights, a small vial sits glowing with a color that seems almost unreal. It isn't the deep red we associate with life, nor the dark purple of deoxygenated veins. Instead, it is a pale, almost metallic blue, like liquid sapphire. This is horseshoe crab blood, one of the strangest substances in nature, and one of the most valuable fluids on the planet. Most people go through their lives never knowing that their safety, their vaccines, and even the IV drips that flow into their veins in hospitals depend on this very liquid. Yet behind that shimmering color lies a story that begins with chemistry, runs through the tide pools of ancient oceans, and ends in the heart of modern medicine. The secret starts with copper. In humans and most vertebrates, the molecule that carries oxygen in the blood is hemoglobin, built around iron. It is iron that gives our blood its bright red color when oxygenated. But in horseshoe crabs, nature chose a different path. Their oxygen transport system relies on hemocyanin, a molecule built around copper instead of iron. When oxygen binds to copper, the result is a striking blue tint, and so coursing through the veins of these armored survivors is a liquid that looks like it belongs more to the realm of fantasy than biology. But the blue color is just the beginning. Hidden within that blood are cells that scientists have called amoebocytes. At first glance, they don't look like much, just small, pale blobs drifting in the fluid. Yet their behavior is extraordinary. When these cells encounter endotoxins, the dangerous molecules released by certain bacteria, they don't simply attack the invader. They release a clotting agent that gels instantly, trapping the bacteria in place and sealing off the threat. It is a defense system unlike any other, a built-in early warning that can stop infection before it spreads. In the muddy shallows where horseshoe crabs live, surrounded by countless microbes, this adaptation is a matter of survival. Their bodies are often wounded by rough sand, sharp shells, or predators, and without a rapid immune response, infection would be certain. Over hundreds of millions of years, natural selection fine-tuned their blood into a kind of living alarm system, hypersensitive, fast, and incredibly effective. The brilliance of this system went unnoticed by humans for centuries. Coastal communities saw horseshoe crabs as little more than pests, useful only for bait or fertilizer. Their strange blood was ignored. It wasn't until the mid-20th century that scientists began to uncover its remarkable properties. In the 1960s, researchers discovered that the clotting reaction of horseshoe crab amoebocytes was the most sensitive natural detector of bacterial contamination ever found. A single drop of blood could reveal the presence of dangerous endotoxins at concentrations so low that no human-made test could match it. This discovery changed medicine forever. Hospitals, pharmaceutical companies, and medical device manufacturers suddenly had a tool that could guarantee safety at an unprecedented level. Every syringe, every IV drip, every surgical implant could be tested using an extract from horseshoe crab blood called limulus amoebocyte lysate, or LAL. If the fluid clotted, the material was contaminated. If it stayed clear, the device was safe. It was simple, elegant, and incredibly effective. Today, the scale of its use is almost unimaginable. Every single vaccine you've ever taken, from childhood polio shots to the most recent COVID-19 vaccine, was tested with horseshoe crab blood. Every hip replacement, every pacemaker, every dialysis machine was cleared with the same process. Without it, the risk of bacterial contamination would be far higher, and modern medicine as we know it might not function at all. The demand for this blue blood has created an entire industry. Along the Atlantic coast of the United States, from New Jersey down to the Carolinas, companies capture hundreds of thousands of horseshoe crabs every year. The animals are brought into labs where their blood is carefully extracted, often about 1/3 of their total volume, before being returned to the sea. The blood is then processed, purified, and sold at prices that can exceed $15,000 a quart. By weight, it is one of the most expensive liquids in the world. For humans, it is priceless. For the crabs, it is a burden. While many survive the bleeding process, not all do. Some estimates suggest that up to 30% die after being returned to the water. Others are weakened, making them more vulnerable to predators or less likely to spawn. The very trait that made them survivors of ancient Earth has, in modern times, placed them under intense pressure. And yet, without their blood, our world would look very different. The delicate vials of vaccine that line refrigerators, the sterile tools used in operating rooms, the artificial joints and valves that extend human life, all of these are guarded, in a sense, by the blue blood of a creature that still crawls ashore by moonlight, unaware of the role it plays in our survival. It is a strange paradox. The horseshoe crab's blood evolved to protect itself from microscopic dangers in the mud. Now it protects us from microscopic dangers in hospitals and clinics. The same defense system that once kept a creature alive in a shallow tidal pool now safeguards billions of people around the globe. But this dependency raises questions. How much can we take before the balance tips? Can a species that has survived for nearly 500 million years withstand the pressures of industrial harvest and habitat loss? And will humans, who rely so deeply on this bizarre blue liquid, find a way to protect the creatures that make it? For now, every time a needle pierces a patient's skin, every time a device is implanted or a drug is delivered, the unseen guardian of that moment is the blood of a horseshoe crab. It is one of nature's strangest gifts, blue, alien, and absolutely vital. On certain spring nights, when the tide runs highest and the moon glows full above the horizon, the beaches of the Atlantic coast begin to move. At first, it seems like shadows shifting under the surf. Then the shapes become clear. Hundreds, then thousands of horseshoe crabs emerging from the water. Their shells gleam in the moonlight, their tails carve grooves in the sand, and together they crawl ashore in one of the oldest and most mysterious rituals on Earth. For nearly 500 billion years, this has been their way of ensuring survival. The females, larger and rounder than the males, haul themselves up the wet sand, sometimes with 3 or 4 males clinging to their shells. When she digs a shallow nest with her legs, she releases thousands of tiny green eggs into the sand. The males then fertilize them, and the waves gently wash over the nest, hiding the treasure beneath the grains. In one night, a single female can lay up to 90,000 eggs. Multiply that by thousands of females along a single stretch of coast, and the numbers swell into the millions. It is a spectacle of abundance. The tide carries the smell of the ocean, the rustle of waves mixes with the scraping of shells, and the beach becomes alive with movement. For people watching, it can feel like stepping into prehistory, a reminder that these creatures were performing this dance long before humans walked the earth. And yet, what looks like a simple spawning ritual is in fact the beating heart of an entire ecosystem. The eggs, laid in such massive numbers, do not all hatch. Many never get the chance. Shorebirds, fish, and other animals quickly discover the feast. Migratory birds, especially the red knot, time their entire journey around this moment, flying thousands of miles from the southern tip of South America to the Arctic tundra. The red knots arrive on the Delaware Bay at just the right time to gorge themselves on horseshoe crab eggs. Without this food, they cannot complete their migration or breed successfully. The horseshoe crab, by following its ancient instinct, fuels one of the most remarkable bird journeys in the world. Fish, too, depend on the eggs. Striped bass, flounder, and other species feed on the abundance left behind in the sand. Even turtles and mammals will take advantage when they can. In this way, the spawning ritual is more than just reproduction. It is a massive pulse of energy into the food web, a seasonal gift that supports countless lives. The eggs that escape predation undergo a transformation of their own. Within weeks, tiny trilobite-like larvae emerge, looking strikingly similar to the fossils of their ancestors. They drift in the surf, carried by currents, feeding and growing until they are ready to settle on the sandy bottom. Over the course of several molts, they begin to take on the familiar armored form of the adult. From egg to larva to juvenile, the cycle of survival continues, repeating the same pattern that has endured for hundreds of millions of years. What's striking is the precision of the timing. Horseshoe crabs don't just spawn randomly, they synchronize with the lunar cycle, climbing ashore during the highest spring tides. This gives their eggs the best chance of being buried deep enough to stay moist, yet close enough to the surface to hatch. It is as though the moon itself has become a metronome for their survival, ticking away the rhythm of their existence across the ages. For indigenous peoples and early coastal settlers, the spawning ritual was a familiar sight. Some used the crabs for food or tools, others simply observed the strange creatures as part of the natural rhythm of the seasons. But for modern scientists, studying the spawning has revealed more than just biology. It has shown how tightly linked ecosystems can be. A change in horseshoe crab numbers ripples outward, affecting birds, fish, and even humans who depend on those species. The moonlit crawl, beautiful and ancient, is also fragile. In recent decades, the number of spawning horseshoe crabs in certain regions has declined. Overharvesting for bait, habitat loss along beaches, and the demand for their blood in medical testing all contribute to reduced populations. And with fewer eggs in the sand, birds like the red knot suffer dramatic declines as well. What was once a guaranteed feast has, in some years, become scarce. Conservationists now monitor the spawning carefully, counting crabs on beaches, tracking bird populations, and urging protective measures to ensure that the moonlit ritual does not fade into memory. Standing on a beach during such a night, it's easy to feel a sense of wonder. The sight of ancient creatures carrying out the same act they performed for hundreds of millions of years is humbling. The air smells of salt and sand, the sound of waves mingles with the clicking of shells, and everywhere you look, life is in motion. To think that within each buried clutch of eggs lies the possibility of another 450 million year journey is almost too large to grasp. But it is also a reminder of responsibility. The horseshoe crab's ritual is not just its own, it belongs to the shorebirds that fly unimaginable distances, to the fish that rely on the eggs for food, to the people who benefit from the creature's blood in hospitals. It is a ritual that binds together species and ecosystems, time and tide, past and present. When the tide recedes and the moon sets, the beach grows quiet again. The crabs return to the water, leaving behind only small disturbances in the sand where the eggs lie hidden. To the untrained eye, it looks like nothing at all, but beneath the surface, a story older than the dinosaurs continues to unfold, one that has shaped life on this coast for longer than we can truly imagine. For most of their long history, horseshoe crabs lived unnoticed by humans. They crawled along the shallow sea floors, spawned on moonlit beaches and shed their shells without drawing much attention. Indigenous peoples sometimes used them for food or tools, but their presence was never in danger. The true shift began much later, when industrial societies along the Atlantic coast began to see these armored creatures not as curiosities of nature, but as resources to be harvested. By the 1800s, coastal communities had discovered that the tough, seemingly endless supply of horseshoe crabs could be put to use in farming. Farmers, always looking for fertilizer to enrich their fields, realized that piles of crabs left to rot produced a powerful stench, and beneath that stench, a potent source of nutrients. Wagon loads of horseshoe crabs were collected from beaches and dumped onto farmland, their bodies ground into fertilizer for crops. In some towns, entire industries formed around this practice. What had once been moonlit gatherings of millions of crabs became harvest grounds, their shells piled in heaps taller than a man. The scale of the harvest was staggering. In Delaware, New Jersey, and along other parts of the mid-Atlantic coast, annual collections numbered in the millions. Some estimates suggest that by the early 20th century, as many as 4 million horseshoe crabs were being killed each year just for fertilizer. Beaches that had once been alive with crawling shells began to thin out. Still, few worried. The crabs had always seemed endless, an inexhaustible tide of living fossils that would never run dry. As fertilizer use declined with the rise of chemical alternatives, the demand for horseshoe crabs did not disappear. Instead, it shifted. Fishermen discovered that the crabs made excellent bait, particularly for eels and whelks, which were valuable in local markets and export trade. A single female horseshoe crab, heavy with eggs, could be cut into pieces and bait dozens of eel pots. Once again, the harvest soared. Thousands upon thousands were collected, stored in buckets, chopped apart, and lowered into the sea to lure other creatures. For the horseshoe crab, it was another wave of pressure. Populations dipped. Beaches where spawning once covered every inch of sand grew quieter. And yet, even then, few people imagined that these strange animals held any importance beyond bait and fertilizer. They were treated as expendable, a resource to be taken with little thought to long-term survival. Then in the mid-20th century, science revealed the true value of the horseshoe crab, hidden not in its shell, not in its meat, but in its blood. The discovery of the clotting reaction of amebocytes revolutionized medical safety testing. Almost overnight, horseshoe crab blood became more valuable than any other part of its body. The harvest changed shape. No longer were crabs simply ground into fertilizer or chopped for bait. Now they were collected by biomedical companies, taken into sterile labs and bled for their shimmering blue lifeblood. Unlike earlier industries, this one did not always kill the crabs outright. After being bled, many were returned to the water, but survival rates were uncertain, and the scale of collection grew rapidly. By the late 20th century, hundreds of thousands of horseshoe crabs were being harvested each year along the U.S. East Coast. The economics were undeniable. A quart of horseshoe crab blood could sell for more than $15,000. By weight, it was worth far more than gold, and unlike gold, it could not be mined or manufactured. Every drop had to come from living creatures, collected one by one, bled under careful laboratory conditions, and then returned to the sea. The industry justified its work by pointing to the countless human lives protected by the tests derived from this blood, and in truth the contribution was immeasurable. Every vaccine, every implant, every IV drip passed through the safety net provided by the horseshoe crab. Yet for the crabs themselves, the pressure mounted. Not only were they still being harvested for bait in many places, but now they were also being tapped for blood. Add to that the ongoing loss of coastal habitats, where development erased spawning beaches, and the picture grew grim. Populations in some regions fell dramatically, conservationists sounded alarms, scientists began counting crabs during spawning runs, noting the decline. Bird populations tied to the eggs, like the red knot, also plummeted, sending another warning that the system as a whole was under stress. By the early 2000s, regulations began to appear. States along the Atlantic introduced limits on how many crabs could be taken for bait. Sanctuaries were created, protecting key spawning beaches. Biomedical companies faced increasing scrutiny, required to release crabs back to the sea after bleeding. Some began funding conservation programs or supporting research into synthetic alternatives to the blood. Yet the demand for the real thing never fully went away, and harvesting continued. To walk along a beach during spawning season today is to witness both the survival and the fragility of this species. There are still nights when the sand comes, alive with thousands of shells. There are still tides when the moonlit ritual unfolds as it always has, but there are also stretches of coastline where the numbers are noticeably lower, where the ritual seems quieter than it should be. And hovering over it all is the knowledge that the very survival of these creatures is entangled with our own. The history of horseshoe crab harvest is, in many ways, a story of shifting human values. First, they were seen as fertilizer, useful only when ground into the earth. Then they were bait, expendable fuel for catching other species. Now they are guardians of health, prized not for their bodies, but for the bizarre blue liquid inside. Each shift has placed different pressures on their populations. Each has revealed new connections between their survival and ours. And each has forced us to ask the same question: how much can we take from a species before we take too much? The irony is sharp. The creature that has survived asteroid strikes, ice ages, and mass extinctions now faces one of its greatest threats from us. A species that has only been here for a fraction of its time. Whether the horseshoe crab remains a fixture of moonlit beaches for future generations will depend not on ancient resilience, but on modern choices. Step into any hospital anywhere in the world and you will find an invisible guardian at work. It is not a doctor in a white coat nor a machine humming beside a patient's bed. It is something older, stranger, and far less obvious. It is the blue blood of a horseshoe crab, woven silently into the very foundation of modern medicine. Every syringe, every IV bag, every vial of vaccine that comes into contact with human blood must be free of dangerous bacterial contamination. Even a trace amount of endotoxin, the toxic molecules shed by certain bacteria, can trigger fever, shock, or even death. Detecting those endotoxins with precision is one of the most critical steps in medicine. And for that task, no technology has proven more reliable than the clotting reaction of horseshoe crab blood. The process begins with the amebocytes, the peculiar immune cells that drift inside the crab's copper-blue plasma. When they sense endotoxins, they release proteins that cause the blood to gel instantly. In the wild, this reaction helps the crab survive in muddy waters, sealing off wounds before infections can spread. In the laboratory, the same reaction is harnessed through an extract called limulus amebocyte lysate, or LAL. A small amount of this lysate is mixed with a sample from a medical device or drug. If endotoxins are present, the fluid clots, signaling contamination. If it remains clear, the product is safe. The simplicity of the test is deceptive. Behind that clot is one of the most sensitive detection systems in nature. Horseshoe crab. Blood can detect endotoxin concentrations as low as a few parts per trillion, levels so faint that no human-made sensor has ever matched it. That sensitivity is why, for decades, no alternative has been able to fully replace the LAL test. Think about what that means in practice. When a baby receives a vaccine, the safety of that injection was verified in part by the blood of a horseshoe crab. When a surgeon implants an artificial heart valve, the sterility of that device was confirmed by the same test. When intravenous drugs are delivered to patients in intensive care units, they have passed through the same safety net. In many ways, every human life that has been extended by modern medicine owes an unseen debt to these ancient creatures. The reach of this system is global. The United States, Europe, Asia all rely on LAL testing. Each year, hundreds of millions of medical devices and pharmaceutical products are cleared through this process. Without it, the risk of contamination would rise dramatically, and confidence in the safety of medicine would falter. In this sense, the horseshoe crab is not just a creature of American beaches, it is a silent partner in human health worldwide. The scale of demand has, of course, placed immense pressure on horseshoe crab populations. Along the US Atlantic coast, hundreds of thousands are collected every year for bleeding. Similar practices have expanded in Asia, particularly in China, where related species of horseshoe crabs are also tapped for their blood. Each crab is restrained, a needle inserted into the tissue near its heart, and as much as a third of its blood is drained into sterile containers. The liquid is then processed, the clotting proteins extracted, and the crabs are returned to the sea. On paper, the system is sustainable. The animals are not killed outright, and many are released back into their habitats. But in reality, mortality rates are significant. Some crabs do not survive the bleeding process. Others are weakened, unable to spawn successfully afterward. Studies have suggested that mortality may range from 10 to 30%, depending on the methods used. In a world where hundreds of thousands are collected each year, those numbers add up quickly. The biomedical industry has long defended its practices, pointing out that without LAL testing, modern healthcare would face unacceptable risks. And they are right, the contribution of horseshoe crab blood cannot be overstated. But conservationists argue that the line between necessity and exploitation must be carefully managed. Too much pressure and the species could collapse. Too little oversight, and the ripple effects could devastate migratory birds, coastal ecosystems, and even human health itself. In recent years, scientists have sought alternatives. One promising solution is recombinant factor C, or RFC, a lab-made version of the key clotting protein found in horseshoe crab blood. Developed through genetic engineering, RFC can detect endotoxins without relying on live animals. In laboratory tests, it has proven just as sensitive as the traditional LAL test. Some pharmaceutical companies have already begun adopting it, especially in Europe. The US Food and Drug Administration has also approved its use. Yet adoption has been slow, in part due to regulatory inertia and the deep trust built over decades in the tried and true LAL method. For now then, the guardianship continues. On moonlit beaches, horseshoe crabs crawl ashore as they have for eons, laying eggs in the sand. In sterile labs, their blood is drawn, processed and transformed into vials of LAL that stand guard over human health. Few patients ever know of this connection. Few realize that the safety of their medicine is linked to a creature that looks like it belongs in a prehistoric sea. But whether they know it or not, the bond is there, woven quietly into the fabric of survival. It is a strange partnership, one born not of intention but of necessity. The horseshoe crab never chose to protect us. Its blood evolved to protect itself in waters filled with bacteria millions of years before the first human appeared. Yet by chance, that system became the shield for our species as well. It is a reminder of how deeply connected life can be, how the fate of a modern hospital ward can hinge on the biology of an ancient creature crawling ashore under the moon. And so, in every vaccine, every sterile syringe, every piece of life-saving technology, the presence of the horseshoe crab lingers, unseen, uncelebrated, but vital. They are not doctors or nurses, not scientists or engineers. They are guardians from another age, their blood carrying secrets that keep us alive. If survival was simply a matter of time, the horseshoe crab would be invincible. It has already endured 450 million years of shifting seas, drifting continents, and extinction events that swept away most of the life around it. But the modern world tests it in ways no asteroid or ice age ever did. The greatest challenge now is not nature's fury, but human ambition. On the beaches of Delaware Bay, one of the last great strongholds of the American horseshoe crab, the scene at spawning time is still dramatic. As the tide rises, thousands of crabs emerge from the surf, females dragging males behind them as they clamber ashore to deposit their eggs. The sand trembles under their armored bodies. Gulls wheel overhead, and shorebirds peck frantically at the exposed eggs. For a moment, it feels eternal, like nothing could interrupt this ancient ritual. But step back from the shoreline, and the fractures become visible. All along the Atlantic coast, the habitats horseshoe crabs depend on are under pressure. Beaches where they once spawned in abundance have been eroded by rising seas or reshaped by human development. Seawalls, jetties, and bulkheads harden the shoreline, robbing crabs of the soft sand they need to bury their eggs. Coastal construction doesn't just erase habitat, it also alters the delicate rhythm of tides, changing where and how crabs can come ashore. Even where beaches remain, the disturbance of constant human traffic, artificial lighting, and pollution disrupts the crab's reproductive cycles. Overharvesting remains another looming threat. Though regulations now exist, horseshoe crabs are still collected in large numbers, both for bait and for biomedical use. In parts of Asia, the situation is even more dire. Populations of Asian horseshoe crabs have collapsed in many regions, driven by demand not only for their blood, but also for their meat, which is considered a delicacy in some markets. In places where crabs were once abundant, spawning runs have dwindled to a fraction of their former size. The consequences ripple outward. Horseshoe crab eggs are the lifeline for migratory shorebirds, most famously the red knot, a small, rust-colored bird that travels from the southern tip of South America all the way to the Arctic each year. To complete this journey, the birds must refuel in Delaware Bay, gorging on crab eggs to build the fat reserves that carry them north. When crab populations decline, the eggs disappear, and so do the birds. The red knot population has already fallen sharply, earning it threatened status in the United States. In this way, the struggle of the horseshoe crab is not its own alone. It is entwined with the survival of entire ecosystems. Climate change adds yet another layer of uncertainty. Rising sea levels are eroding beaches faster than they can naturally rebuild. Warmer ocean temperatures may alter spawning cues, throwing off the timing that has synchronized crabs and birds for millennia. Stronger storms churn the coastline, washing away eggs before they can hatch. Ocean acidification, the slow creeping result of carbon dioxide dissolving into seawater, could interfere with the ability of larvae to build their shells. All of these pressures converge on a species that has always been slow to reproduce, with females taking nearly a decade to reach maturity. Despite these threats, the horseshoe crab persists, a testament to resilience. But resilience is not invulnerability. The line between survival and collapse is thinner than it seems. In some regions, local populations have already disappeared. In others, the numbers are falling year by year, despite efforts at conservation. The strange irony is that the same species humans depend on for life-saving medical technology is, in many places, struggling to hold its own against human activity. Conservationists are fighting back. Protected beaches have been established in places like Delaware Bay, where human traffic is restricted during spawning season to give crabs and birds the space they need. Harvest quotas have been tightened, limiting the number of crabs that can be taken for bait. Biomedical companies have been pressed to refine their bleeding practices, reducing mortality and investing in alternatives like recombinant factor C. Education programs aim to remind coastal communities that the crab crawling ashore under the moon is not just another strange sea creature, but a keystone of their ecosystem and a silent partner in global health. Still, the struggle is far from won. For every beach preserved, another is lost to development. For every population stabilized, another remains in decline. The balance is delicate and the margin for error is slim. The horseshoe crab does not need miracles to survive, only space to spawn, time to mature, and restraint from human hands. But whether it will be granted those things remains an open question. To stand on a beach at night and watch a horseshoe crab dig into the sand is to witness persistence made flesh. Its shell glistens in the moonlight, its tail spine drags furrows behind it, and its legs push steadily forward as if nothing in the world could interrupt its ancient mission. And yet, hovering over this simple act is the weight of all the challenges of the modern world. The creature has the tools to endure, but not the power to resist every pressure we place upon it. Its fate now lies not in its biology alone, but in the choices we make. The struggles of the horseshoe crab remind us that even the most enduring survivors are not beyond reach of collapse. That survival is not just a matter of resilience, but of relationship between species, between ecosystems, between the ancient and the modern. Whether the horseshoe crab continues to crawl under the moonlight for another 100 million years may depend not on the tides or the stars, but on us. For centuries, the horseshoe crab has been taken for granted. It was treated as fertilizer, bait, and a living factory for medical safety. Yet in recent decades, something has shifted. Alongside the harvest and decline, voices have risen in defense of this ancient survivor. A quiet movement has grown, one that sees in the crab not just a resource, but a living bridge between past and future, science and nature, survival and responsibility. This movement is the foundation of conservation. One of the most important battlegrounds is Delaware Bay, often called the horseshoe crab capital of the world. For generations, the bay has been the single most vital spawning ground for the Atlantic horseshoe crab, where millions once crawled ashore to lay their eggs. By the 1990s, however, overharvesting had driven the population into steep decline. The consequences were stark. The red knot, a migratory bird whose survival depends on crab eggs, plummeted in numbers. Alarm bells rang through the conservation community, sparking urgent action. Regulators responded by tightening limits on the bait harvest. States like New Jersey and Delaware introduced strict quotas, while New Jersey went further, imposing a complete moratorium on taking horseshoe crabs for bait. These steps were not always popular with fishermen, who had long relied on crabs to fuel their eel and whelk catches. Yet they marked a turning point, signaling that the species' survival was no longer to be sacrificed for short-term gain. Biomedical companies too began facing scrutiny. Public pressure and scientific research pushed them toward more careful practices. Today, crabs collected for bleeding are supposed to be returned alive, and laboratories are increasingly transparent about their methods. Mortality still occurs, but efforts to minimize stress and improve release conditions have grown. Some companies have even begun funding conservation programs, recognizing that their industry depends on the continued health of wild populations. Beyond regulation and industry, grassroots efforts have played a crucial role. Volunteers gather on beaches during spawning season to monitor crab numbers, rescue stranded animals, and collect data for scientists. These community counts have provided some of the most detailed records of population trends, turning ordinary citizens into guardians of an ancient species. Schools, museums, and aquariums have joined in, teaching children about the importance of horseshoe crabs and the delicate web of life they support. The arrival of recombinant factor C has added a new dimension of hope. This synthetic alternative to horseshoe crab blood has the potential to dramatically reduce reliance on wild animals. In Europe, several major pharmaceutical companies have already transitioned fully to RFC testing. In the United States, adoption has been slower, but momentum is building. Each new company that embraces the technology reduces the pressure on crab populations, moving medicine one step closer to a future where life-saving safety tests no longer depend on bleeding a living fossil. Internationally, the picture is mixed. In Asia, where populations have been hit hardest, conservation efforts face steep challenges. Habitat loss, overfishing, and cultural demand for crab meat make protection difficult. Yet even there, hope flickers. In parts of China, sanctuaries have been created to protect spawning beaches. In Singapore, education campaigns have raised awareness about the species' plight. And across Southeast Asia, scientists are working to establish breeding programs that could one day restore dwindling populations. At the heart of conservation lies a simple truth. Protecting horseshoe crabs protects far more than just one species. Their eggs sustain migratory birds that cross hemispheres. Their presence stabilizes coastal ecosystems that buffer human communities against storms. Their blood safeguards medical systems that save millions of human lives. To conserve the horseshoe crab is to conserve an entire network of connections, many of which we are only beginning to understand. And there is something deeper too, something beyond science or utility. There is the awe of watching a creature that predates dinosaurs crawl ashore under a full moon. There is the recognition that survival is not just about efficiency, but about endurance and chance. The horseshoe crab embodies resilience on a scale we can barely imagine. To lose it would not only be a blow to ecosystems and medicine, but a fracture in our shared story of life on Earth. Conservation, then, is not only about saving horseshoe crabs. It is also about saving our sense of continuity, our link to a world far older than humanity, and our responsibility to those who cannot speak for themselves. Each rescued crab, each protected beach, each shift towards sustainable practice is an act of respect, an acknowledgement that our fate is bound to theirs. As the moonlight spills over a spawning beach, volunteers kneel in the sand, flipping stranded crabs back onto their bellies, counting pairs, marking observations in notebooks. It is quiet work, often overlooked, but it carries the weight of hope. Every crab returned to the water, every egg laid safely in the sand, every data point recorded is a small victory in a larger struggle. And while the challenges remain immense, the presence of people willing to care, to fight, and to change the way we live alongside these creatures may be the greatest source of hope of all. In a quiet laboratory somewhere on the East Coast, a tiny drop of blue liquid sits under the microscope. It glimmers softly, like sunlight refracted through a jewel, and yet this small substance holds the potential to transform the future. This is the blue blood of the horseshoe crab, the same fluid that has protected human health for decades. And yet the question now is whether humanity can continue to rely on it without threatening the creature itself. For decades, the biomedical Industry has depended on LAL testing, a process that extracts blood from living horseshoe crabs to detect bacterial contamination. It is a system that works extraordinarily well, and its global adoption has saved countless lives. But reliance on live animals has consequences. Mortality rates, stress from handling, and disruption of spawning cycles all contribute to population pressures. Scientists have long recognized that if the demand for LAL remains unchecked, even a species as resilient as the horseshoe crab could face serious declines. The solution, it turns out, may lie in biology itself. Researchers have been working for years on synthetic alternatives to LAL. Recombinant factor C, or RFC, is one of the most promising breakthroughs. It is a genetically engineered protein that mimics the clotting reaction of horseshoe crab amoebocytes. In laboratory tests, RFC has proven to be just as sensitive as natural LAL, detecting trace levels of endotoxin with equal precision. The advantage is clear. No live animals are required, and the test can be produced consistently and in unlimited quantities. Regulatory approval has been a slow process. Pharmaceutical companies and government agencies have relied on decades of validation using natural LAL. Introducing a new standard for safety is never simple, yet momentum is growing. In Europe, RFC has already been widely adopted, and several large US pharmaceutical companies are beginning to follow suit. If adoption continues, it could drastically reduce the number of horseshoe crabs harvested each year, giving wild populations a chance to recover while maintaining the safety of medical products worldwide. Ethical considerations also come into play. The horseshoe crab is more than a resource. It is a sentient, living organism with its own evolutionary history. It has survived mass extinctions, ice ages, and the rise and fall of countless other species. To continue bleeding it for human convenience raises questions about stewardship and responsibility. By adopting synthetic alternatives, humanity acknowledges that survival and ethics are not mutually exclusive, and that the oldest species on Earth deserves protection, not exploitation. Technology alone, however, cannot solve every problem. Habitat preservation remains critical. Even if blood harvesting were eliminated entirely, horseshoe crabs still face threats from coastal development, pollution, and climate change. Spawning beaches must be protected, water quality maintained, and public awareness increased. Without these measures, the species could decline even if the demand for blood disappears. In this sense, the future of the blue blood is inseparable from the future of the crab itself. Scientists are also exploring ways to improve population monitoring. Tagging programs, satellite tracking, and drone surveys now allow researchers to follow the movements of individual crabs, document spawning events, and track population trends over time. These technologies offer hope that interventions can be targeted, effective, and minimally disruptive. For the first time, humans can gain a precise understanding of how these ancient creatures live, reproduce, and interact with their environment, giving conservation efforts a data-driven foundation. The potential of biotechnology extends even further. Some researchers are investigating whether genetic insights from horseshoe crabs could be used to improve human medicine. The amoebocyte's clotting ability, honed over hundreds of millions of years, represents a natural immune system that has evolved in ways modern science is only beginning to understand. Could studying horseshoe crab biology lead to new treatments, new vaccines, or novel antimicrobial strategies? The possibilities are tantalizing, reinforcing the notion that protecting the species is not only ethically responsible, but scientifically wise. Public engagement also plays a critical role. Education campaigns on beaches, in aquariums, and through digital media are teaching people to appreciate the crab's ecological and medical importance. Volunteers participate in spawning surveys, rescue stranded crabs, and even advocate for policy changes. These grassroots efforts create a culture of stewardship, connecting local communities to global conservation goals. Every child who learns the story of the horseshoe crab is a potential advocate for its survival, ensuring that the species' legacy continues. In the long view, the future of the blue blood is a story of interdependence. Humans depend on horseshoe crabs for medical safety, while the crabs depend on humans for protection, habitat preservation, and restraint from overharvesting. It is a relationship unlike any other, where ancient biology intersects with modern ethics and technology. The choices we make in the coming decades will determine whether this partnership endures or falters. Some nights, when the moon rises, over the Atlantic coast, thousands of horseshoe crabs emerge once more, continuing a ritual that has survived mass extinctions and geological upheaval. If we act wisely, these creatures will continue to crawl ashore, spawn, and shed their shells for generations to come. If we fail, the blue blood that has safeguarded human lives may become a memory, a relic of a bond that was broken too soon. The future is not yet written. The blue blood flows resilient and ancient, shimmering with the same light it has carried for hundreds of millions of years. And in that shimmer lies both a warning and a promise. Protect the crabs, honor their place in the world, and we protect ourselves. Neglect them, and we risk losing not only a living fossil, but a piece of the delicate balance that makes life possible. To stand on a quiet beach at night, when the tides are low and the moon casts a silver glow across the sand, is to witness a miracle that has endured for nearly 500 million years. The horseshoe crab, armored and prehistoric, crawls slowly toward the water's edge. Its shell glints, its legs push steadily through the sand, and its tail, called a telson, balances and anchors it as if guiding the way. It is a creature that has survived the rise and fall of continents, the extinction of dinosaurs, and countless environmental upheavals. Yet, in our modern era, it has become something far more than a survivor. It has become a bridge between the past and the present, between the natural world and human ingenuity. Few species have a story that intertwines biology and human culture as seamlessly as the horseshoe crab. For indigenous peoples and early coastal communities, it was a source of food and tools, a creature woven into local knowledge and folklore. As industrial society emerged, it became a resource, first fertilizer, then bait, and later a vital component of the medical industry. Its blood, blue and shimmering, became a lifeline for humanity, a natural technology more sophisticated than any human invention. The very thing that evolved to protect the crab in tidal waters now protects millions of human lives worldwide. The legacy of the horseshoe crab is also a lesson in balance. Its survival reminds us that life does not exist in isolation. The crab's eggs feed migratory birds that travel across hemispheres. Its presence supports coastal ecosystems that buffer human communities against storms and erosion. Its blood safeguards medical treatments that extend and save lives. One species, ancient and unassuming, is linked to countless others in a network that spans oceans and generations. To protect the horseshoe crab is to protect far more than a single creature. It is to protect the threads that connect life itself. Modern conservation efforts illustrate the power of awareness and action. Protected beaches, harvest restrictions, and synthetic alternatives to blood extraction all represent humanity's capacity to respond when we understand the stakes. Volunteers monitor spawning events, rescuing stranded crabs and recording vital data. Scientists study their behavior, map their populations, and refine techniques to reduce mortality from harvesting. Policymakers balance industry needs with ecological imperatives, recognizing that short-term profit must yield to long-term survival. Together, these actions create a mosaic of hope, a reminder that even ancient species can endure when humans act responsibly. The story of the horseshoe crab also highlights the unpredictability of nature. Despite surviving 450 million years, it is now vulnerable to human pressures. Its continued existence is no longer guaranteed by resilience alone. It is contingent on our choices, our ethics, and our willingness to recognize our interconnectedness with other forms of life. There is humility in that realization. A species that existed long before humans walked the earth now holds a mirror to our own practices, showing both the ingenuity and the responsibility that come with power. There is also wonder in the simplicity of its life cycle. Each year, under the full moon, crabs return to the beaches to spawn. Eggs are laid, fertilized, and left to the rhythm of the tides. Birds feed, larvae hatch, and a new generation begins. The process is ancient, unbroken, and astonishingly precise. Time itself seems to slow in these moments, reminding us that the natural world has rhythms far older than human calendars, seasons that endure no matter how much the world changes. The horseshoe crab's blue blood remains a symbol of ingenuity and adaptation. Scientists continue to study it, not only for its medical utility, but also for insights into evolution and immunity. The amoebocyte's extraordinary sensitivity to bacterial toxins offers clues about innate immunity, mechanisms that could inspire new medical breakthroughs. Each vial of blood, each laboratory experiment, is a testament to the marriage of ancient biology and modern science, a reminder that even creatures seemingly unchanged for hundreds of millions of years have secrets yet to reveal. Education and storytelling play a crucial role in cementing the crab's legacy. By sharing its story, communities cultivate appreciation for the interconnectedness of life. Children learn that a small creature crawling across the sand under moonlight holds significance for birds, fish, humans, and the tides themselves. Documentaries, articles, and public outreach help translate ecological and medical importance into a shared sense of responsibility. The horseshoe crab becomes more than a subject of study. It becomes a teacher showing patience, resilience, and the profound value of life that exists beyond immediate human concerns. Looking toward the future, the balance between human needs and ecological stewardship remains delicate. Advances in biotechnology like recombinant factor C offer the promise of reducing the strain on wild populations. Habitat preservation and thoughtful regulation ensure that spawning beaches remain viable for generations of crabs and the birds that depend on them. Citizen science programs and global cooperation extend awareness beyond local communities, connecting people across continents to the fate of a single species. In this way, the future of the horseshoe crab is tied not only to biology, but to human choices, culture, and conscience. Ultimately, the legacy of the horseshoe crab is one of continuity and connection. It is a living relic that has survived mass extinctions, a provider of eggs and blood, a guardian of human health, and a witness to the ebb and flow of life on Earth. Its story reminds us that survival is rarely solitary, that ecosystems, species, and human societies are woven together in intricate, fragile patterns. And it teaches that responsibility, awareness, and care can ensure that even the most ancient creatures continue their rhythms for millennia to come. As the final wave of crabs returns to the surf, disappearing beneath the shimmering reflection of the moon, one cannot help but feel awe and gratitude. The sand is dotted with the marks of countless journeys, the faint echoes of a ritual that predates written history. Each crab that survives, each egg that hatches, each drop of blue blood that contributes to human health, carries forward a story older than civilization itself. It is a story of endurance, adaptation, and the profound interconnectedness of life, a story that, if we choose wisely, will continue long into the future. The horseshoe crab, in all its alien elegance, is a teacher, a guardian, and a survivor. Its legacy is not only written in the sand in the oceans or in laboratory vials, but in the choices we make, the ecosystems we protect, and the respect we show for life that has endured far longer than we have. To witness it, to understand it, and to act for it is to participate in a chain that stretches back hundreds of millions of years and forward into generations yet unborn. In the end, the story of the horseshoe crab is also our own. It is a reminder that longevity alone is not enough, that survival demands adaptation, protection, and mutual respect. It challenges us to think beyond immediate utility, to consider the intricate web of life, and to recognize that even the smallest creatures can hold the keys to our own well-being. The blue blood flows, the moonlight shimmers, and the crabs continue their eternal march, a living testament to endurance, mystery, and hope.